Today we get to start off on the fun subject of proofs, geometry proofs. They are a challenge for most students. However, we'll be working on them throughout the year and they will become easier and easier. First of all, what is a proof? It uses deductive reasoning to come up with answers. Well, what's deductive reasoning? It's when you take a general concept and then use evidence to bring it down to one point or a specific point. For example, if you are a detective and you're trying to solve a murder mystery, you may have several suspects, people that you believe murdered the person at the beginning of your work. Then you continue to find evidence that allows you to come down to the conclusion that one person is responsible for the murder. That was deductive reasoning. You use a general concept and you bring it down to one logical answer. Let's go ahead and take a look at an example of a proof. And in this proof, I want you to focus in on only one thing at a time. So let's go ahead and take a look only at the top part of this. Looking at the picture here with statements and reasons. First of all, look at the diagram. That's where you're going to start with every proof. Look at the picture. Then the second step is to go ahead and take a look at what you're supposed to be finding. For example, in this case, it says, what's the value of x? So look at the picture. How are you going to know the value of x? Well, the first thing you can do is take a look at what they give you. Oftentimes, the first step is given to you in a math proof. The first step, in this case, oh, by the way, please label the left side statements. That's what you'll do every time in a two-column proof. And the right side is reasons. They gave us this angle AOM, which I'll highlight in yellow. A to O to M, this angle right in here. Oh, this angle right in there. And then we have angle MOC in red. Those two angles are supplementary. They state that. Well, how does the publisher know that these are supplementary? They notice that we have angles that form a linear pair. Linear pair, we haven't really covered that yet. Just want to make sure you understand what a linear pair is. It's just like what the word states. Linear, meaning a line, and a pair. We have one angle that goes from here to here. And then we have the second angle over here. And so it continues on. And notice how we made a nice little protractor there? So that means that we have angle 1 plus angle 2 equals 180 degrees, which makes these two a linear pair. A pair of angles that create a line. I'm going to go ahead and erase all those marks I put all over this so that you can read it easier. So let's go ahead and take a look at what we can conclude from this. We have a diagram, we have first statement given to us. What can help me find my value of x in this? This word supplementary is significant because if I know that these two angles are supplementary, we should know, I know it's been a while, but supplementary means two angles added together equal 180. So let's add the two angles and set them equal to 180. The reason I know that is because I recall the definition of supplementary. Now I'm still trying to find the value of x. There's no x written here. What I can do is I can go back to my diagram, look at AOM. Notice it has 2x plus 30 degrees. So let's go ahead and substitute that in. Replace AOM with 2x plus 30 degrees. And substitute the MOC angle over here with the x. So we have 2x plus 30 degrees and plus the x degrees, these two separate little angles, we add them together and set them equal to 180. How did we move from this step to this step? Substitution. So we wrote substitution as our reason for writing that. And I'm still trying to find the value of x. So what can I conclude from what's over here? How do I get the value of x? Well, when I take a look at this picture or the math problem, I'll notice I have two like terms, 2x and x. 2x plus x is 3x. So we have 3x plus 30 equals 180, just combining 2x and x. So why did I do it? Combine like terms. What's my next step? Take a look at the math problem on the left side. I'm trying to find x. That's my whole goal. So if I'm trying to find x, the next thing you would logically do in math is to go ahead, recalling your algebra skills, and put minus 30, because we need to get x by itself. We need to get rid of the 30. So if you're subtracting x from both sides, you'll come to the conclusion that 3x equals 150. If we subtract 30 from both sides, that's called the subtraction property of equality. So we just write down subtraction property. Now, the next thing we need to do is we take a look at our math problem. We're still trying to figure out what is x worth. I'm going to bring this down a little bit so I have room. 3x equals 150. If you were just given that as a math problem, you would say, oh, divide by 3 on both sides, because I need to get a single x. 3 divided by 3 allows you to get 1x. 150 divided by 3 allows you to get 50. What did I do up here? I did division. So all I do is write division property of equality. Let's review real quick what we did on this proof. First of all, we look at the diagram. That's step 1. Step 2, we look at what we're supposed to be finding out. What are we supposed to be proving? The value of x. If we look at the diagram, what general concepts do we know that matches this picture? Well, you just learned what a linear pair is. So these two angles add up to 180. They are supplementary. So then we follow logic and start moving into our math problem by substitution and solving for x. Now, every proof is going to be different, but the steps are the same as far as look at the diagram, look at what you're supposed to try to prove, and go through your evidence and bring it down to one answer. These are some of the reasons that you can use on the right side of any proof. The first grouping here of the first 4, you'll find this in your book, by the way. These are all your algebra properties where you just subtract the same number from both sides or add the same number to both sides. It's how you solve those 2-step problems that you learned in Algebra 1. This next grouping here, these are more of geometry. You probably have not seen them before. A equals A. I know that sounds ridiculous. You'll learn more about it later of why we actually do that for geometry. The next thing we have is symmetric property. And symmetric, you just flip these. If A equals B, then B equals A. Transitive property is the most common one that you see. And that means what we do is we say A equals B, B equals C. Well, if A equals B and B equals C, shouldn't A and C be the same thing also? So that's a logical conclusion. Now, what will I do with this? You'll find out later on through our proofs what we do with these properties. Just recall that you have this list of properties to go to draw from, as reasons when you work through proofs. We'll go ahead and stop this video for here and start up on a new topic on the second video for this homework session. Take a breather, take a break. See you in a minute.